Welcome to the Copperfield Electric Podcast.
Thanks for having me.
Imagine bringing home this brand new $60,000 electric vehicle.
Oh, that's always a great feeling.
Right. You pull into your garage, you were just thrilled to never visit a gas station again. But then you realize your home's electrical panel is essentially going to reject this car like a bad organ transplant.
Yeah, it happens way more often than you would think.
Today, we are looking at the hidden secondary purchase that routinely crashes the EV party. And that's the home charger.
Because the transition from internal combustion to electric, well, it changes your driveway from a parking spot into a localized fueling station.
Exactly.
You are fundamentally altering your home's energy ecosystem. And, the learning curve catches a lot of people completely off guard.
So our mission for you on this deep dive is to guide you through the surprisingly complex decision of choosing the right home EV charger. We are going to specifically look at the battle between Tesla chargers and universal chargers.
Which is a huge debate right now.
It really is.
Yeah.
And we're going to unpack the physical realities of actually getting that hardware safely operating on your wall. To do this, we are pulling insights directly from a recently published guide by Renee Hernandez, dated August 9, 2026.
Yeah, and we're also looking at the internal service blueprints of Copperfield Electric.
Right, which gives us a great behind-the-scenes look.
Exactly. And just to give you some context on the experts behind those blueprints, Copperfield Electric, they operate under license number 1094740. They are a family-owned business serving Southern California.
Right in our backyard.
Yeah, their operations specifically focus on Orange County areas, so places like Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, and Mission Viejo.
And they have a pretty solid reputation, right?
Oh, definitely. They offer a 100% satisfaction guarantee and a 24-hour rapid response. So, having access to their service blueprints allows us to look past all the marketing brochures. We get to see what actually happens when an electrician opens up a garage wall.
Which is exactly what we need.
What's fascinating here is that while EV adoption is skyrocketing, the actual driveway infrastructure, the physical connection point at your house, remains heavily fragmented.
Yeah, it's a mess.
To understand what equipment you need, we really have to start with the physical hardware and the battle of the plugs.
Okay, let's unpack this, because looking at this landscape, it feels exactly like that transition we all went through with our smartphones.
Oh, the different charging cables.
Right. Remember when every electronics brand had a different proprietary phone charger? And then thankfully, we finally started migrating toward a standard USB-C.
Yeah, that was a nightmare.
It's incredibly frustrating when a guest comes over and, they can't even charge their device at your house. But scaling that problem up to a vehicle, that just seems like a massive oversight by the auto industry.
It really is a significant hurdle. I mean, the most visible difference between charging units is literally the physical plug you insert into the car. So on one side, we have Tesla's standard wall connector. This unit uses what they call the NACS plug, which stands for North American Charging Standard.
Even though it wasn't exactly standard at first?
Exactly. Historically, despite the name, it has been an exclusive proprietary plug for Tesla vehicles only. So if you mount that standard Tesla charger in your garage, you are fundamentally restricting your fueling capability to one single brand.
Wow. And for everyone who doesn't drive a Tesla, the Hernandez guide mentions the industry standard for those vehicles is something called J1772. Which honestly sounds more like a barcode than a consumer product.
Yeah, it's not the catchiest name. The J1772 designation actually comes from the Society of Automotive Engineers.
Okay.
And it has been the absolute standard plug for non-Tesla EVs for over a decade. If you drive an electric Chevy, a Ford, a Hyundai, or, almost any other automaker's EV, you've been relying on a J1772 plug.
So it's pretty ubiquitous outside of Tesla.
Very much so. But it is larger and bulkier than the Tesla plug. That's because it separates the pins for AC power delivery, the grounding, and the communication signal between the car and the charger.
Okay, that makes sense. But the sources note that universal EV chargers, like Tesla's own universal wall connector, actually ship with the J1772 connector, but also include a built-in NACS adapter.
Yes, that's right.
So it can charge the Chevy natively, but then, utilize the adapter to charge the Tesla. It acts as a bridge.
And that bridging capability is crucial right now, because the automotive industry is in a highly volatile transition state.
How so?
Well, since 2025, most major automakers have actually started shifting toward the NECS, the Tesla standard, for their newly manufactured models.
Oh, wow. So J1772 is going away.
Eventually, yes. However, There are millions of J1772 vehicles still on the road, and those vehicles are going to remain in circulation, changing hands on the used market, and basically sitting in our driveways for many years to come.
So you really need to handle both.
Hmm.
I want to look at the performance metrics of these units, though, because if I am utilizing an adapter or a universal system, my first concern is whether I am, like, bottlenecking the power.
Sure, that's a common worry.
If I buy the Tesla Standard versus the Tesla Universal, does that compatibility come at the expense of speed?
Not at all. Performance remains identical across both Tesla models. They are engineered to deliver up to 44 miles of range per hour when operating at a 48 amp capacity.
Okay, that's pretty fast.
It is. And both units also utilize integrated Wi-Fi to connect to the Tesla app. So that allows for remote scheduling and real-time monitoring of the power flow.
The blueprints also detail third-party network chargers, right? Like the ChargePoint Home Flex.
Yeah, that's a very popular one.
And it looks like those add about 30 to 40 miles of range per hour. But the standout feature for the third-party units seems to be adjustable amperage.
Yes, that is a huge factor.
Which allows the installer to dial the power demand up or down based on the home's specific electrical constraints.
And that adjustable amperage is a vital mechanical feature we will explore when we get to the actual installation part. But, sticking to the hardware selection for a second, making this choice requires shifting your perspective.
How do you mean?
Well, you aren't just outfitting the garage for the car parked there today. You really have to anticipate the vehicles that will park there a decade from now.
That brings us to the logistics of living with these varying standards. The Hernandez Guide gets into this whole adapter shuffle concept, the long-term real estate value of the hardware, and a debate between what it calls smart versus dumb tech.
It's a lot to consider.
It really is. Let's look at the adapters first. The guide says they go in both directions and cost between $20 and $50. Now, I have a major issue with the financial logic here.
Go ahead, let's hear it.
Okay, if these adapters are only $20 to $50, why on earth would anyone pay a premium for a universal charger? The Tesla Universal Wall Connector is significantly more expensive than the standard model.
That's true, it is.
So why wouldn't a homeowner just purchase the absolute cheapest standard unit on the market and, I don't know, throw a cheap $50 adapter in the glove box to cover their bases?
If we connect this to the bigger picture, you have to look beyond just the upfront retail price. You have to examine the physical mechanics and the daily friction of it all.
The daily friction.
Yeah, let's look at a multi-EV household. Say one person drives a Tesla, the other drives a Hyundai. If you rely on a loose adapter, you are physically snapping it on and pulling it off every single day.
Right.
The adapter shuffle means you're eventually dropping it on the concrete, exposing it to dust, or, accidentally leaving it in the trunk of the car that just drove away to work.
Sure, the daily friction of losing the adapter is annoying. I'll give you that. But is avoiding a minor daily annoyance really worth paying a premium up front?
It is not just about annoyance. It is fundamentally about electrical safety and physics.
It's safety, really.
Yeah. Yes. Every time you add a mechanical connection to an electrical circuit, like snapping an adapter onto a plug, you are introducing a point of electrical resistance.
Oh, I see where this is going.
Right. When you push a massive, continuous 48 amp load through a physical connection for 6 to 8 hours a night, that resistance generates heat.
Wow, so a cheap, frequently dropped $50 adapter could actually become a thermal hazard over time.
Exactly. Wear and tear on the pins inside a loose adapter increases that resistance. A built-in universal charger eliminates that weak point.
Because it's integrated.
Yeah. The adapter is integrated, secured, and engineered to handle the thermal load seamlessly. And, beyond the physics, there is a massive real estate implication here.
Like when you go to sell the house.
Precisely. If you intend to sell your property, a prospective buyer driving a Ford or Hyundai will look at a Tesla-only charger in the garage and view it as a limitation.
That makes total sense.
They will mentally deduct the cost of hiring an electrician to rip it out and replace it.
But if they walk in and see a universal charger, it operates as a turnkey solution regardless of what they drive. It elevates the home's infrastructure.
Exactly. It's a selling point.
Now, moving to the software side, I'm looking at this guide. And Hernandez mentions dumb chargers. To me, that just sounds like buying obsolete tech on purpose, when everything else in our lives is digitized.
I know, it sounds counterintuitive.
Yeah.
But there is a really strong mechanical argument for dumb technology.
Really? Like what?
Well, smart chargers, like the Tesla units or the ChargePoint, they rely on internal Wi-Fi chips, microprocessors, and sometimes even digital displays to connect to an app and schedule off-peak charging.
Right, which sounds great.
It is, until it breaks. A dumb charger is entirely basic. It consists of the heavy gauge wiring, the physical connector, and the internal safety relays. You plug it in, power flows. You unplug it, the flow stops.
So why strip away all those helpful software features?
Because of the operating environment. I mean, a garage in Southern California can easily reach 110 degrees in the summer.
Oh, yeah. It gets brutal.
And complex electronic components like Wi-Fi transmitters and silicon chips are highly sensitive to extreme heat and thermal cycling. By stripping those out, a dumb charger trades the convenience of an app for rugged mechanical reliability.
That makes a lot of sense, actually.
Yeah, fewer delicate parts simply mean a lower probability of catastrophic failure over a 10-year lifespan.
Okay, so we've navigated the hardware. Whether we choose smart, dumb, universal, or standard, we now have to actually mount this thing to the wall and power it.
This is the fun part.
And the Copperfield electric blueprints reveal a massive misconception in the EV market right here. The brand of charger you purchase has absolutely zero bearing on the complexity of the installation.
None whatsoever. The labor and the raw electrical requirements are identical across the board. The brand only changes the equipment line item on the invoice.
So the foundation is the same.
Every single installation requires the same baseline foundation. You need a dedicated 240-volt circuit originating from your main electrical panel. You need a correctly sized breaker to safeguard that specific amperage.
And the wiring itself, right?
Yeah, you require properly gauged, heavy copper wire pulled through conduit to handle the continuous load without melting.
The documentation also mandates a formal permit with a city inspection. And if the charger is mounted on an exterior wall, you need a specialized weatherproof enclosure.
All standard stuff.
So the physical labor is a constant. The variable that actually derails these projects isn't the charger at all, it's the home's existing electrical panel capacity.
This is where the physics of electricity dictate the reality of the installation.
Here's where it gets really interesting. You could spend top dollar on a premium 48-amp smart charger, bring it home, and discover your house literally cannot power it.
It happens all the time.
It feels like buying a massive, state-of-the-art flat-screen TV, bringing it home, and realizing the wall you want to mount it on is made of rotting drywall. You can't just hang the TV. You have to fix the foundation of the house first.
That is a perfect analogy.
But electrically, what does that actually mean?
To understand the electrical limitation, we need to distinguish between peak loads and continuous loads and look at volts versus amps.
Yeah, weigh on me.
Think of your home's electrical wiring like a plumbing system. Voltage is the water pressure pushing through the pipes. Amperage is the actual volume of water flowing through those pipes.
So a 240-volt circuit has high pressure, and 48 amps is a massive volume of water.
Precisely. And an EV charger is classified as a continuous load. Unlike a microwave that draws a high volume of water for 2 minutes and then shuts off, an EV charger is the equivalent of opening a fire hydrant in your garage and leaving it running at full blast for 8 hours straight.
That is intense.
It is. The National Electrical Code requires continuous loads to operate at only 80% of the breaker's maximum capacity to prevent the wiring from overheating.
So there's a buffer built in.
Right. So to deliver 48 amps of continuous volume to the car, you actually need a 60-amp breaker.
And when you apply that math to an older home, the problem becomes really obvious. The blueprints show that many older homes were constructed with only 100-amp main electrical panels.
Yeah, and when you look at the total capacity of a 100-amp panel, you have to subtract the volume already being consumed.
By all the other appliances.
Exactly. Your central air conditioner, your electric oven, your clothes dryer, your refrigerator. Those appliances are already eating up a vast majority of that 100-amp capacity.
You can't just slap a new 60-amp breaker on there.
No. If you try to force an additional 60-amp continuous circuit onto that panel, you will overload the system. You'll trip the main breaker, or worse, risk a severe electrical fire.
You simply lack the room in the pipes, which is why the Hernandez Guide emphasizes the absolute necessity of a load calculation. It is basically a mathematical audit of your home's energy consumption.
And a proper load calculation requires a licensed electrician to analyze the square footage of the home, tally the wattage of every permanent appliance, and calculate the maximum potential draw if everything were running simultaneously.
That sounds complicated.
This is a highly technical process where the seasoned technicians at Copperfield Electric step in. They diagnose the panel's true legal capacity.
But what happens if the math comes back and says the panel is totally maxed out? Does the homeowner just have to abandon the whole EV dream?
Not necessarily. In some cases, the mathematics dictate that a full panel upgrade, often moving from 100 amps to 200 amps, is the only safe legal path forward.
Which is not cheap.
No, it's not. But frequently, a skilled technician can utilize that adjustable amperage feature we discussed earlier.
All right, the dial-down feature.
Exactly. By configuring the charger's internal software or the hardware dip switches to only draw, say, 30 amps instead of 48, they can safely fit the EV's continuous load into the existing panel's margins.
And entirely avoid a $10,000 panel upgrade.
Precisely. Having the capacity honestly evaluated prevents homeowners from buying equipment they can't use or paying for massive upgrades they don't actually need.
So, assuming the panel can handle the load, what are the final logistical and financial hurdles before finalizing this infrastructure?
Well, the financial landscape has shifted recently. Historically, homeowners relied on a federal incentive known as the Section 30C tax credit.
I've heard of that one.
Yeah. Mechanics-wise, this allowed a homeowner to deduct 30% of the total cost of the hardware and the installation directly from their federal tax liability. It was a powerful tool for offsetting the cost of panel upgrades and premium chargers.
But the guide states that credit is no longer active.
Right. According to the Hernandez publication, the Section 30C tax credit officially expired on June 30, 2026.
Oh, wow. So it's totally gone.
It is no longer available, which significantly changes the budgeting math for new installations. However, homeowners should investigate local utility programs.
Like what?
Southern California Edison, for example, they frequently run localized rebate programs that can still apply to the hardware or the electrical upgrades.
That's good to know. The physical logistics of the equipment also present some hidden traps, though, particularly regarding the length of the charging cable itself.
Oh, yes. Cord length dictates the daily usability of the entire system. Tesla wall connectors are manufactured with a 24-foot cable.
Which seems pretty long.
In a standard garage layout, 24 feet provides enough slack to reach the vehicle's charge port, regardless of whether the car is pulled in forward or backed into the space.
Right, 24 feet seems more than adequate. Why is it a trap then?
Because certain universal models or third-party units ship with shorter cables, sometimes measuring closer to 23 feet.
It's just a 1-foot difference.
One missing foot sounds negligible on a spec sheet, sure. But in physical space, it can be the difference between a cable resting comfortably on the floor and a cable stretched taut like a tripwire across the garage.
Oh, I see.
If the charging station is mounted near the garage door and the car's charge port is located on the opposite rear quarter panel, a 23-foot cable might force you to back your car into the garage every single day just to make the connection.
Wow, you are allowing the hardware to dictate your physical routine. That is annoying. I also want to look at the protection of this investment, because we are talking about hundreds of dollars for the unit and potentially thousands for the installation.
Warranty terms fluctuate dramatically between manufacturers. Tesla currently provides a robust 4-year warranty on both their standard and universal wall connectors.
And the third-party ones?
Conversely, many prominent third-party network chargers only offer 3 years of coverage. And as we discussed with the dumb chargers, a simpler, non-network unit might carry a shorter warranty on paper, but the statistical likelihood of requiring warranty service is lower.
Right, due to the absence of fragile microprocessors.
Exactly.
Now, there is one highly advanced mechanical feature detailed in the sources that completely reframes how we look at panel capacity, and that is power sharing.
Yes, power sharing is an ingenious software solution to a physical hardware bottleneck. Both Tesla models possess the capability to share power across up to 6 separate units operating on the same electrical panel.
Wait, I need to understand the mechanics of that. Because if one charger requires a 60-amp breaker to safely deliver a 48-amp continuous load, how do you put 6 chargers on a standard home panel without just, blowing the main fuse to the street?
The units communicate with each other dynamically over the local Wi-Fi network to throttle the volume of electricity.
Okay, so they talk to each other.
Right. Let's say your panel load calculation determines you only have a total of 48 amps of continuous capacity available for the garage. If you install 2 Tesla chargers, you don't need 2 separate 60-amp breakers. You wire them to share that single pool of available power.
So when 2 vehicles plug in simultaneously, what happens mechanically?
The charger's internal software recognizes the dual demand. They automatically and instantly split the current, delivering 24 amps to car A and 24 amps to car B.
So the charging speed just drops for both.
Yes, the charging speed drops, but the panel remains perfectly safe. And here's the best part. Once car A reaches a full battery and stops drawing current, the software instantly routes the entire 48 amp volume over to car B.
Just to maximize its charging speed.
Exactly.
It constantly monitors the demand and redirects the water pressure to whichever pipe needs it without ever exceeding the total allowed volume for the house. That is a brilliant way to future-proof a home for multiple EVs without requiring a massive commercial-grade electrical overhaul.
It really is. But the guide warns that many third-party units lack the hardware or software to perform this dynamic load balancing.
So if a homeowner anticipates their driveway becoming a multi-EV space over the next decade, verifying that the chosen hardware supports active power sharing is paramount.
Without a doubt.
So what does this all mean for someone listening right now, particularly in Orange County, who just brought home their first electric vehicle and suddenly feels buried under a mountain of load calculations, continuous amp ratings, and thermal resistance warnings?
It means that treating an EV charger installation as a weekend DIY project is a profound mistake. The complexities of thermodynamics, continuous load regulations, and local permitting are entirely unforgiving.
I can imagine.
If an improperly torqued wire on a 48-amp circuit overheats in the middle of the night, the consequences are catastrophic. This is why the sources explicitly point toward utilizing specialized professionals.
And this is where Copperfield Electric comes in. Yeah.
Exactly. If you reside within Copperfield Electric's service area, so their head office is in Tustin, but they cover Laguna Beach, Fullerton, and the surrounding Orange County zones, they are fully equipped to execute this entire process.
From the initial mathematical panel assessment to pulling the specific city permits, running the conduit, and passing the final municipal inspection.
They mitigate the physical risks and they eliminate the guesswork. For listeners in those areas requiring a true load calculation, direct access to Copperfield Electric is available at 626-622-9694 or 949-806-3169.
Engaging a licensed professional is really the only way to safeguard both the vehicle and the structure.
Absolutely.
The core lesson extracted from the Hernandez Guide and these service blueprints is really a complete paradigm shift. Choosing an EV charger is not a vehicle accessory decision. It is a permanent home infrastructure choice.
Completely agree.
It alters the thermal dynamics of your electrical system, it influences your daily physical routine through cord lengths and adapters, and directly impacts the future turnkey appeal of your property. You have to look past the physical plug and evaluate the deep underlying mechanics of your home's foundation.
You are fusing the future of transportation directly into the nervous system of your house. It demands strategic anticipation, not just a quick purchase.
Which brings me to a final thought I want to leave you with, building on the mechanics of power sharing and multi-car households. We are rapidly approaching a reality where every single vehicle in a driveway will demand high-volume, continuous electrical flow.
Oh, that day is coming sooner than people think.
Right. So if the modern garage is destined to operate as a high-capacity fueling depot, we have to wonder, will a home's raw electrical panel capacity eventually supersede its square footage or the view from the backyard as its most valuable real estate selling point?
That is a fascinating question.
Will future homebuyers demand to inspect the amperage of the electrical panel before they even bother looking at the master bathroom?
When the ability to reliably commute to work hinges on the home's infrastructure, the definition of a premium property fundamentally changes.
Something to mull over the next time you plug in. We encourage you to keep asking questions, look closely at the mechanics behind the technology, and definitely check out Copperfield Electric if you're in Southern California and need an expert eye on your home's setup. Thank you so much for joining us on this deep dive. Stay curious, everyone.